Hello and welcome. Today we're going to learn about binomial expansion and binomial probabilities. First, we have to do something. A plus b to the 0 power. That's going to be 1, because anything to the 0 power is 1. Now a plus b to the first power is going to be 1a plus 1b. A plus b to the second power is going to be 1a squared. Then it'd be, now keep in mind this is a plus b times a plus b. So it'd be a squared, ab plus ab, so that would be 2ab. And then the last one will be 1b squared. Now a plus b to the third is taking this answer, a squared plus 2ab plus b squared, and multiplying that by a plus b. To do that, we have a times a squared times a, which is 1a to the third, 2ab times a, that's 2a squared b, a squared times b, so that would be plus 3a squared b. Now I would do a times b squared, so that's 1ab squared, but I could multiply b times 2ab to get 2ab squared, so that would be 3ab squared. And then finally, b squared times b is b to the third power. Now, if we did this again, we would multiply this times a plus b. Now, let's take a second and look for patterns. So let's get rid of this, look for patterns. I have a 1, 1, 1, 1, 1, 1, 1, 1. 2 we can get by adding 1 and 1 to get 2. 3 I can get by adding 1 and 2 to get 3. So now if I follow this pattern, 1, and this is a squared, a to the third. So now we'll do a to the fourth. Now the new number will be 1 plus 3, which is 4. Now see how my a to the third goes to a squared, a, and then it disappears? So let's do the same thing here. This will go a to the third, and now b will start up. Now if I add these two coefficients, I get 6. This would be a squared, b squared. If I add those two coefficients, I get 4, a b to the third, and then finally it ends up b to the fourth. This should be 1, 1. Now, notice how the exponents go 4, 3, 2, 1, 0, 0, 1, 2, 3, 4. So now if I wanted to keep going, a plus b to the n, what are we going to do? How can I label this? Well, first let's look at Pascal's triangle. This is Pascal's triangle. You can see we finished the first 4 rows. The 5th row I can get by adding 1 and 4 to get 5, 6 and 4 to get 10, 6 and 4 to get 10, and 1 and 4 to get 5, and then the 1 on the outside. If I wanted to do the 6th row, it would be 1, those two add together to get 6, those two add together to get 15, then 20, then 15, then 5, and then 1. And we can keep on doing this forever, really. Now, let's see 6 choose 3. Now, if we plug in 6 choose 3 on our calculator, well, let's come back here. Let's do something easier. Let's do 5 choose 3. 5 choose 3 is how many ways we can permutate 5 items if we have 3, so that's 5 times 4 times 3 divided by 3 factorial, 3 times 2 times 1. So if I simplify this, 5 choose 3 is going to be 10. Now where would 10 be here? 10 is in this column, and it's both here and here. Now, 5 choose 3 I can get by Pascal's triangle by saying this is 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3. That's 10. 5 choose 4, 5 choose 5. So if I asked to do 3 choose 2, you'd go 3 choose 0, 3 choose 1, 3 choose 2. That's 3. 6 choose 3, 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3. That would be 20. Hopefully you're getting the hang of how to find your combinations using Pascal's triangle. Now, notice that you use the row that the 6 is in. So if I do 5 choose 3, I use the row that has a 5 in it on the second term. So 6 choose 3, we just did to be 20. Now, if I want to expand up to a plus b to the 7th, let's look at this. This had the same pattern as Pascal's triangle for the coefficients. And the first term, a, starts high and goes down. The second term starts down and goes up. So if I wanted to do this, first thing I would need is my 7th row. So that'd be 1, 7, 21, 35, 35, 20. Ooh, this should be a 6, shouldn't it? 21, 7, 1. Alright, so now if I want to do a plus b to the 7th power, it's going to be 1a to the 7th and b to the 0, so that doesn't need anything. My next coefficient is going to be 7. So I say plus 7, a to the 6th, b to the 1st. My next coefficient will be 21. 21, a to the 5th, b to the 2nd. See how the a's are decreasing in their exponents and the b's are increasing in their exponents. The next one would be 35, a to the 4th, b to the 3rd. Then, well, maybe it'll be easier if I just do this. So we have 35 here, and then we'll do another 35, a to the 3rd, b to the 4th. And then we go to 21, a squared, b to the 5th, plus 7, a, b to the 6th. And then finally we're going to finish it with b to the 7th. And that would be 1, no, and then no a's, a to the 0, and then b to the 7th. Notice how we use the row on Pascal's triangle to figure out all of those coefficients. Alright, now let's expand x plus 2 to the 5th. Alright, so we're going to use the 5th row, 1, 5, 10, 10, 5, 1. So I'm going to write that 1, 5, 10, 10, 5, 1. So it will be x squared, no, x to the 5th, plus 5 x to the 4th, 2 to the 1st, plus 10 x to the 3rd, 2 squared, plus 10 x squared, 2 to the 3rd, plus 5 x 2 to the 4th, and then finally 2 to the 5th power. Alright, so we'll have x squared, or x to the 5th, 2 to the 1st times 5 will be 10x to the 4th. 2 squared is 4, 4 times 10 will be 40x to the 3rd. This will be 2 to the 3rd is 80 times 10, so that would be 80x squared. 2 to the 4th would be 16, 16 times 5 will be 80 again, so that would be plus 80x. And then 2 to the 5th, well, we have 2, 4, 6, or 2, 4, 8, 16. So this would have to be 32. So x plus 2 to the fifth is equal to x to the fifth plus 10x to the fourth plus 40x to the third plus 80x squared plus 80x plus 32. All right, so now you're probably thinking, how do I use this with probabilities? There's some connection. We talked about the connection between combinations and Pascal's triangle. Now, this is all used quite a bit in probability. Imagine a coin is bent so that the probability that you'll get heads when you flip it is 0.4. So the probability of heads is equal to 0.4. If you flip it 5 times, what's the probability that you get exactly 2 heads and 3 tails? Well, that's kind of a tough problem, and we're going to get there. But let's start with an easier problem. What's the probability we get tails, 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 heads, heads? Well, the probability that we get tails on the first one is going to be 0.6. Probability we get tails on the second one is going to be 0.6. Probability we get tails on the third one is 0.6. And then heads on the fourth one is 0.4. Heads on the fifth one is 0.4. So this would be 0.6 to the third times 0.4 squared. Now if I take out my trusty calculator, oops, I hit the wrong button at first. All right, 0.6 to the third times 0.4 to the second power. That gives us 0.03456. 0.03456. Now that's just if it's tails, 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 heads, heads. So now we'll use that, and let's think about the bigger problem. So how many ways can I get 2 tails and 3 heads? Well, we have to think about how many different ways I can get tails, 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 heads, heads, or 3 tails and 2 heads. Now I can do this. I could put the other head here. Now it would take a little bit to list them all out, or we can rely on our combinations knowledge. And if I have 5 items and I want to choose where I put 2 of them, 5 choose 2 is going to be all the different ways I can write 3 T's and 2 H's. So 5 choose 2 is going to be 5 times 4 divided by 2 factorial. So that would be 20 over 2, or 10. Or a smarter person, or not smarter, a person with, maybe a smarter person, would probably use the Pascal triangle. 0, 1, 2. 5 choose 2 is 10. Now notice, someone could be saying, well, how did you know not to do 5 choose 3? Because that's how many ways we can rearrange 3 tails. If I do 5 choose 3, that would be 5 times 4 times 3 divided by 3 factorial, which is still 20 over 2, which is 10. And in the Pascal's triangle, see how it's symmetric? 5 choose 2 and 5 choose 3 will always be the same number. 5 choose 1 and 5 choose 4 will always be the same number. And it's precisely for this reason. So there's 10 different ways I can rearrange these. And the number was 0.03456, I believe. Yes. So now if I multiply those together, that's going to be 0.3456. And that's the probability that I will get 3 tails and 2 heads from that particular coin. So it's the term 5 choose 2 times 0.6 to the third times 0.4 squared. Now I can get that by expanding this. So let's expand using the properties we learned earlier. We do 0.6 to the fifth. And remember, the fifth will be 1, 5, 10, 10, 5, 1. 0.6 to the fifth times 5 times 0.6 to the fourth times 0.4 plus 10 times 0.6 to the third times 0.4 squared plus 10 times 0.6 squared times 0.4 to the third plus 5 times 0.6 to the first times 0.4 to the fourth plus finally 1.4 to the fifth. Now we've expanded this. We've also found out that this one right this right here, 5 choose 2.6 to the third, 0.4 to the second, is the probability that it will get tails 3 times and heads twice. Now each section, each term, represents a different probability. So the probability that it hits heads, yes, probability or that it hits heads 0 times will be 0.6 to the fifth. Now 0.6 to the fifth, I can figure out on my trusty calculator, is to be 0.07776. Alright, the probability that I get 1 head is going to be this probability. 5 times 0.6 to the fourth times 0.4. 5 times 0.6 to the fourth times 0.4, or 0.2592. The probability that I get 2 heads is going to be 10 times 0.6. Oh, we already did that one, right? That was 0.3456. Now let's do probability that we get 3 heads. And notice that this is the amount of heads, so we can always tell that this is 0, 1, 2, 3 heads, 4 heads, and 5 heads. So the probability we get 3 heads, we'll just multiply that out. So 10 times 0.6 to the second times 0.4 to the third, that would be 0.2304. Then 5 times 0.6 times 0.4 to the fourth, 0.0768. And then finally, the probability that they're all heads, that's 0.01024. Now if I take all of these probabilities and add them up, I should equal 1. And you can take the time if you want to. They will equal 1. They should equal 1. As long as you notice that that's actually a 7 and not a 1. But in any situation, all the probabilities have to equal 1. And if you get something where they don't add up to 1, there's usually you did something wrong. And one of the biggest problems people make is they don't remember how to, they forget to put the combination in front of each of those. Alright, so I did that on the previous slide. So if I wanted to make a probability distribution, now your book does it a little bit different than an AP Stats class would. They use a dot plot, or like a scatter plot. And I guess it works. So let's say this is 0.1, 0.1, 0.15, 0.2, that would be 0.3. Now we'll take all of the probabilities here and then graph them. So 0.07, 0.07 is going to be about there. then it's 0.25, and then 0.34, 0.25, 0.34, 0.23, and 0.07. And then 1%, which is going to be down there. So you can see that the probabilities increase and then they decrease. So what is the probability that a coin lands heads up at least 2 out of 5 times? So let's look at the word at least. At least means 2 or more. So if we look at this, we just have to add up the 2, 3, 4, and 5. So that's going to be 0.3456 plus 0.2304 plus 0.0768 plus 0.01024. And I got 0.66304. 0.66304. So about 66% of the time, you'll get 2 or more heads. So this is a binomial probability distribution. This is the definition of what we've just done. So suppose a random experiment consists of repetitions of the same action, where the action has 2 possible outcomes. Let E be the 2 possible outcomes. Let B be the event that E occurs, A be the event that it doesn't occur, and X be the number of times the event occurs in n repetitions. So then the probability of X will be n choose X times X to the n minus X times B to the X. That's a formula. It works, but if you understand how to use the binomial expansion, you don't actually have to use the formula each time. All right, so now we're going to use a problem in this situation. A short multiple choice quiz has 4 questions, each with 5 possible answers. Wooly Passive has not studied, and he guesses answers at random. What is the probability that his answer on a given question is correct? And what's the probability that his answer is incorrect? So we have 5 possible answers. So the probability that is correct is 0.2. The probability that is incorrect is 0.8. So he has 4 questions. We want to find the probability of 0, probability of 1, probability of 2, probability of 3, and the probability of 4 questions being right. All right. So the probability that it's 0, we're going to do 4 choose 0. So the 2 probabilities are 0.2 and 0.8. So he gets 0 correct and 4 incorrect. Now this next one is going to be 4 choose 1, and he gets 1 correct and 3 incorrect. 1 correct and 3 incorrect. Probability that he gets 2 right, we do 4 choose 2, 0.2 to the second power, because he gets 2 correct, and 0.8 to the second power, because he gets 2 correct. And then this one would be 4 choose 3, 0.2 to the third power, 0.8 to the first power, and then 4 choose 4, 0.2 to the fourth power, 0.8 to the 0 power. Hopefully that makes sense to everybody. So here he gets 4 correct, 0 incorrect. Now I'm going to calculate. So here are the probabilities for Willie to get 0 through 4 correct on that test. So use the fact that probability should add to 1 to check your answers, so just add all those up. And now, hopefully you can sketch a probability distribution graph. So we'll have a probability down here, 0, 1, 2, 3, 4. And then do this, 0.1, 0.2, 0.3, 0.4. So this one is going to be about 0.4. It's about the same probability the second one. Then 0.15, then 0.2, then 0.1. So notice how this one starts high and then goes down sharply. So the probability of Willie doing well in the test is very, very low. The probability he gets 0 or 1 correct is pretty high. All right, here's your homework for tonight. Good luck.